So good morning students. So I am Dr.S.Jothilakshmi, Assistant Professor of Computer Science, the Standard Fireworks Rajarathinam College for Women, Sivagasi. So in this lecture video, so you are going to learn about deadlock recovery. So these are the objectives of this tutorial class. So what is deadlock? How deadlock is occurred? So necessary condition of deadlock, then deadlock recovery. So first we see about what is deadlock. So deadlock is a situation, so in a computer, so here two or more processes unable to proceed because so each process is waiting for other one. So these are the conditions of deadlock. So mutual exclusion, resource holding, circular wait and no preemption. So consider an example when two trains are coming towards each other on the same track and there is only one track. So here none of the trains can move once they are in front of others. So this is the practical example of deadlock. So next one, how does deadlock occur in the operating system? So before going in detail about the deadlock occur in the operating system, so let us first discuss how operating system use the resources present. So a process in a operating system use resources in the following way. So the first one is the request a resource, use the resources, release the resources. For example, a situation occurs in operating system when three processors, two or more, that hold some resources and wait for resources held by others. For example, processor 1 is holding a resource 1 and waiting for a resource 2, so which is acquired by process 2, and process 2 waiting for resource 1. These are the some examples of deadlock listed here. So there are several examples of deadlock. Some of them are mentioned here. So the first one, the system has two tape drives P0 and P1, each hold on tape drive and each need another one. The second one, semaphores A and B initialized to 1. P0 and P1 are the deadlock as follows. So P0 executes and wait and preempts. So P0 executes and wait and the process P is waited. Now P0 and P1 entered in deadlock. So these are the necessary conditions of deadlock. So there are four conditions that result in deadlock. These four conditions are known as the deadlock condition. So the first one is the mutual exclusion, hold and wait, no preemption, circular wait. So let us see one by one. So mutual exclusion. So this is the one type of a deadlock. So here a resource can be held by only one process at a time. So in other words, if a process P1 is using some resources or at a particular time and the some other process P2 cannot hold or use the same resource or at the particular instant of time, the process P2 can make a request for the resource R, but it cannot be use that resource simultaneously with process P1. So here the resource R is allocated to the process, then the resources is wanted by more than one process. So another deadlock condition is hold and wait. A process can hold a number of resources at a time and at the same time. So it can request for other resources that are being held by some other process. For example, a process P1 can hold two resources R1 and R2 at the same time. It can be request some resources R3. So that is currently held by process P2. So here there are two processes, one is the P1 and another one is the P2, and the resources are R1, R2 and R3. So first the resources R1 and R2 allocated to the process P1. The process R3 is, the process P2 is then request the resources R3. So here the process are holded and wait for other process. So the next condition is no preemption. So here resources can be preempted from the process by another process forcefully. For example, if a process P1 is using some resource R, then some other process P2 cannot forcefully take that resources. If it is so, then what's the need for various scheduling algorithm? The process P2 can request for the resource R and can wait for the resources to be freed by the process P1. And another condition is circular wait. So circular wait is a condition when the first process is waiting for the resource held by the second process is waiting for the resource held by the third process, and so on. At least the last process is waiting for the process held by the first process. So every process is waiting for each other to release the resource, and no one is releasing their own resources. So everyone is waiting here for getting the resources. So this is called circular wait. The process is waiting in a circular manner. So next we are going to see about the deadlock recovery. So once deadlock has been detected in the system, the deadlock must be broken by removing one or more of the four necessary conditions. So here one or more process will have to be preempted, thus releasing their resources so that the other deadlock processes can be unblocked. So the first deadlock recovery condition is process termination. So in this case, the deadlock is removed by aborting a process, but aborting process is not easy. So all deadlocked processes are aborted. So the second one, the circular wait is eliminated by aborting one by one process. There will be lot of overhead. So the deadlock detection algorithm must return after each process kill. So here the selection of process for aborting is difficult. So here we are using the parameters. The parameters are listed here. So the first one is priority of the process. The second one is what percentage of the process finished is execution. Then resource used by the process. Then need for resources to complete the process remaining operations. So how many processes will need to be terminated? Then process type, batch or iterative. So when the process is terminated, we have to follow these parameters. So first we check the priority of the process. Then next, what percentage of the process is finished its execution. We have to check the execution of the process. Then next one, what are the resources used by the process. We have to check the resources. Then next one, needed of resources to complete process remaining operation. We have to check the remaining operation of the resources. Then how many process will need to be terminated. We have to identify what are the process will need to be terminated. Then next we have to check the process type, batch or iterative. The second one is resource preemption. So here the resource temporarily take away from its current process and allocate it to another process. For selecting victim, following factors are considered. So first we have to check priority of the process. The higher priority process are usually not selected. Then we have to check the CPU time used by the process. The process which it close to completion are usually not selected. The number of other process that would be affected if this process were selected as the victim. So the next one is the starvation. So starvation is one type of situation, so in which a process wait for an event that might never occur in the system. So select the victim only for finite number of time. Use rollback method for selecting victim process. So in this lecture video, so you studied about the what is deadlock, then conditions of deadlock, how the deadlocks are removed in the operating system. So thank you for listening this video. Thank you.